Hello students, today we will be solving the IB Math AHL November 2023 paper 1 question number 12. You will be getting the previously solved questions of this paper and of the other papers in form of playlists in my channel NS Online Math Tutoring classes. You will also be getting playlist where you will be getting solved past paper questions grouped in terms of topics. You will be getting a playlist where you will be getting all the questions related to vectors. Similarly, you will be getting another playlist where you will be having all questions related to complex numbers. So they will be grouped by the topics. I'm Nilanjana Sanyal. I'm an online IB Math AHL tutor. In case you want to join my sessions, please contact me for more details. My phone number and my website link are given below at the bottom of the screen. So without any further delay, let us start answering question number 12. The maximum mark is 17. The first part says, find the binomial expansion of cos theta plus I sin theta whole raised to the power of 5. Give your answer in the form of a plus b I, where a and b are expressed in terms of sin theta and cos theta. Now, as soon as students read this cos theta plus I sin theta to the power of 5 has to be expanded using the binomial expansion theorem, they can do that. But just after reading the next sentence, give your answer in the form of e plus bi, they get confused. There's no point in getting confused. First of all, let us use the binomial expansion theorem to get the terms. Okay. So it is cos theta plus I sin theta raised to the power of 5 should be equal to 5c0 cos to the power of 5 theta and I sin theta to the power of 0 plus 5c1 cos to the power of 4 theta and I sin theta to the power of 1 plus 5c2 cos to the power of 3 theta I sin theta to the power of 2. The first term's power goes on decreasing and the second term's power goes on increasing. 5c3 cos to the power of 2 cos square theta and I sin theta to the power of 3 plus 5c4 cos theta and I sin theta to the power of 4 plus 5c5. You can write cos to the power of 0 theta. I am not writing, though I have written over here. Let me just skip that part and I am just writing I sin theta to the power of 5. Okay, so this is the expansion, and of course now I have to simplify. 5c0 is of course equal to 1 and I sin theta to the power of 0 is also equal to 1. So the first term is cos to the power of 5 theta. Second term, 5c1. NC1 is always equal to n, but in case you do not know, you are confused, it is paper 1, so you will not be getting the help of the calculator. It is 5 factorial over 1 factorial times 5 minus 1 factorial and I sin theta to the power of 1. So there will be the I part. I am writing the I over here. Okay. And cos to the power of 4 theta sin theta plus 5c2. And this is I square. So this will not be a plus sign. I square is minus. So we will be having a minus sign. And 5c2 is 5 factorial over 2 factorial times 5 minus 2 factorial. And cos cube theta and sin square theta. And now it is I cube. I cube is I square times I. I square is negative 1. So I can write negative I squared times I squared is negative 1, times I is negative I, and 5c3, 5 factorial over 3 factorial and 5 minus 3 factorial, and cos square theta sine cube theta, plus, always remember NC0 and NCn, they are equal to 1, and NC1 and NCn minus 1, they are equal to n. 5c4 and I to the power of 4. I to the power of 4 is what? I square. Let me write it over here. I to the power of 4 is equal to I square times I square, which is equal to negative 1 times negative 1, which is positive 1. I cube was equal to I square times I. So this is negative 1 times I, which is equal to negative I. Okay. So this is how I am calculating. So I come to 5c4, and I to the power of 4 is plus 1. So I do not have to write anything or change the sign. 5 factorial over 4 factorial and 5 minus 4 factorial cos theta and sine to the power of 4 theta, and 5c5 and I to the power of 5. I to the power of 5 is how much? It is I to the power of 4 times I. And we have seen I to the power of 4 is 1. So it is 1 times I, which is equal to I. Okay. So it is plus I times 5 factorial over 5 factorial and 5 minus 5 factorial, which is 0 factorial. And 0 factorial is always equal to 1. And sine to the power of 5 theta. Okay. So this is cos to the power of 5 theta. And this is 5 factorial over 4 factorial. 5 factorial is what? 5 times 5. 5 factorial is 5 times 4 factorial. So this is 4 factorial, and in the numerator we will be having 5 times 4 factorial. So it will be this and this will be getting cancelled. So it will be 5. So I can write 5 cos to the power of 4 theta sine theta I. You can write I at the first as well. And now coming to this. 5 factorial is 5 times 4 times 3 factorial. And this is 3 factorial. It is getting cancelled. This part is getting cancelled. In the denominator, you have the 2 factorial. 2 factorial is 2. So these two will be getting cancelled and you will be having 10. So minus 10 cos cube theta sine square theta. And now again minus. This is 5 minus 3 is 2. And this same expression holds over here. I can write this is 3 factorial. This was 2 factorial times 3 factorial. This is also 3 factorial times 2 factorial. And the numerator is the same 5 factorial. So it has to be 10. 10 cos square theta sine cube theta. This is 3 sine cube theta. And then it is, and I have to write the I also. And then it is this one. 5 minus 4 is 1 factorial. 1 factorial is of course 1, and this is 4 factorial, and this is 5 factorial is 5 times 4 factorial. So again it has to be 5. So 5 cos theta sine to the power of 4 theta, and this is 1 factorial and this is 5 factorial over 5 factorial, hence it is 1. So plus sine to the power of 5 theta I. So this is the expansion. And now I have to write it in this format, a plus bi. So I have to just group the real and the imaginary parts together. So this is cos to the power of 5 cos to the power of 5 theta. And then I am having this one minus 10 cos cube theta sine square theta. Okay, and then this one plus 5 cos theta sine to the power of 4 theta. This part is E and plus I bi. So I have to put plus sign in between. Since they have written I later after B, so I'll be writing I last. So this is the first term, first imaginary term. So it is 5 cos to the power of 4 theta sine theta. And then it is this one minus 10 cos square theta sine cube theta. And finally this one plus sine to the power of 5 theta. I. So this will be the answer for the Sapati. Okay. Sapat B. By using de Moivre's theorem and your answer to Sapat A, show that sine 5 theta is equivalent to 16 sine to the power of 5 theta minus 20 sine cube theta plus 5 sine theta containing 6 marks. Okay. So, and what was the expression? Cos theta plus I sine theta raised to the power of 5. To this, we will be applying the de Moivre's theorem. Okay. So, using de Moivre's theorem, cos theta plus I sine theta to the power of 5 is equal to cos 5 theta plus I sine 5 theta. Okay. Therefore, I am taking I sine 5 theta because they have asked us to get the expression for sine 5 theta. This is the imaginary part. I'll be taking this imaginary portion. Okay. So, sine theta, I'm not writing the I. The I's will be getting cancelled. If you write this I and this I, they will get cancelled. So, sorry, it is sine 5 theta. 5 theta equal to 5 cos to the power of 4 theta sine theta minus 10 cos square theta sine cube theta plus sine to the power of 5 theta. And now you see that we have equated, fine. But in the equation given, you don't have any cos theta. So therefore, we have to don't assume that what you have done is wrong because they did not have any cos term and we are having some cos portions. You are absolutely correct, but you have to just convert the cos to sine. And what will be the conversion rule? It is sine square theta plus cos square theta equal to 1. The first trigonometric identity that we have learned so far. Yes, you have tan theta equal to sine over cos, but I take this to be the first basic identity that I had learned. So cos square theta equal to 1 minus sine square theta. Okay. So what is cos to the power of 4 theta? Cos to the power of 4 theta. Cos to the power of 4 theta is not equal to 1 minus sine to the power of 4 theta. Never make this mistake. Cos to the power of 4 theta is cos square theta whole square. Okay. So this is equal to 1 minus sine square theta whole square. So this is 5. In place of cos to the power of 4 theta, I am writing 1 minus sine square theta whole square and sine theta minus 10 cos square theta, so it is 1 minus sine square theta, and sine cube theta plus sine to the power of 5 theta. Okay, so this is, I'll be expanding this one, 5 a minus b whole square is equal to a square, that is 1 square, minus 2ab, so minus 2 times 1 times sine square theta, so it is minus 2 sine square theta, and plus b square. So sine square theta whole square is sine to the power of 4 theta. And this is getting multiplied by sine theta. And for this, you are having 10 times 1 is 10 times sine cube theta is minus 10 sine cube theta. And for this, negative 10 times negative sine square theta is positive 10 sine square theta times sine cube theta is plus 10 sine to the power of 5 theta plus sine to the power of 5 theta. Okay, so this is equal to, I am expanding this, 5 times 1 is 5 times sine theta. So 5 sine theta. This one is sine square theta times sine theta is sine cube theta, and 5 times 2 is 10. So minus 10 sine cube theta, and this one is sine to the power of 4 theta times sine theta is sine to the power of 5 theta, and there is this 5 in front. So plus 5 sine to the power of 5 theta minus 10 sine cube theta plus 10 sine to the power of 5 theta plus sine to the power of 5 theta. Now we will be grouping the like terms. First of all, they have written most probably, what did they write? They have started with sine to the power of 5 theta. Okay, let's see. So this is 5 sine to the power of 5 theta. This is 10 sine to the power of 5 theta. And this is 1 sine to the power of 5 theta. So 5 plus 10 plus 1 is 16. So this is equal to 16 sine to the power of 5 theta. Then there is the cube part. It is, this is 10 and this is 10. So minus 20 sine to the power of 3 theta. And then there is the sine theta plus 5 sine theta. Are we having this expression? Yes. 16 sine to the power of 5 theta minus 20 sine cube theta plus 5 sine theta. Okay. So we have shown this. Subpart C, it is containing two further subparts. The first subpart is saying, hence show, and this was proved in the subpart B. Sine 5 theta is equivalent to 16 sine to the power of 5 theta minus 20 sine cube theta plus 5 sine theta. Hence show theta equal to pi over 5 and theta equal to 3 pi over 5, and the other solutions of the equation 16 sine to the power of 4 theta minus 20 sine square theta plus sine equal plus 5 equal to 0. Now you see, this is 16 and this is 16 because they have said hence. So we have to relate this to the previous part. So this is 16 and that is 16. This is negative 20. That is negative 20. This is positive 5. That is positive 5. That part is fine. But over here, the powers are not the same. This is sine to the power of 4 theta. This is 5 sine to the power of 5 theta. This is sine square theta. This is sine cube theta. And this over here, it is sine to the power of 0 theta, in fact. But over here, you are having sine theta to the power of 1. So how to relate, how to come to this equation? You can come to this equation if you take this sine theta common. So let us do that. Okay. So sine 5 theta is equivalent to 16 sine to the power of 5 theta minus 20 sine square theta plus 5 sine theta. So this is, if I take out sine, then what happens? Sine theta, it is 16 sine to the power of 4 theta minus 20 sine theta. It was sine cube, sorry. Sine cube. So this is sine square theta and plus 5. Okay. So we have got this part. Fine. But how do I prove this to be equal to 0? Because this side is containing sine 5 theta. Okay, let us, because I need this part, so let us first of all divide the entire equation by this sine theta. So we get sine 5 theta over sine theta. This is how you have to think. That is why I am saying all these. Because you need this part, but you are having this extra part. So just you have to get rid of that. So what can you do? You have to divide the entire equation by sine theta. I do not know what to do to this part, but at least I will be getting this portion in one part of the equal to sign. So I'm doing that. 16 sine to the power of 4 theta minus 20 sine square theta plus 5. Okay. And they are saying that theta equal to pi over 5 and theta equal to 3 pi over 5 are the solutions. So we do not know how to prove, and it is paper 1. So let us just substitute pi over 5 in place of theta. Because if you have, say, if you have x squared minus 4x plus 4 equal to 0, then, and you are said that x equal to 2 is a solution. Then how do you prove that x equal to 2 is a solution? You will be substituting 2 in place of x over here, and you will be getting 4. 2 square is 4, and this will be 4 times 2 is 8, and this is plus 4, and this is indeed equal to 0. So the left hand side is equal to the right hand side. Hence, x equal to 2 is a solution for this equation. Okay, so they are saying that theta equal to pi over 5 is a solution. So let us substitute pi over 5 in place of theta in this equation. Okay, but we are not having this equation. In fact, we are having this equation. So I'll be substituting pi over 5 over here in place of theta. Okay, so sine 5 times pi over 5, because it is sine 5 theta, over sine pi over 5 is equal to 16 sine to the power of 4 pi over 5 minus 20 sine square pi over 5 plus 5. Okay, and so this part is equal to this part. So if I can show that this part is equal to 0, then I can say that definitely theta equal to pi over 5 is a solution of this equation. Okay, so what is this? Left hand side. This and this will be getting cancelled. So sine pi over sine pi over 5. But what is sine pi? It is equal to 0, which is equal to 0. And 0 divided by anything is 0. This is equal to 16 sine to the power of 4 pi over 5 minus 20 sine squared pi over 5 plus 5. Hence, theta equal to pi over 5 is a solution. Similarly, I will be taking the 3 pi over 5. And I'll be using the same equation. I don't have any other equation. So it is sine 5 times 3 pi over 5, and these two will be getting cancelled, and sine 3 pi is again equal to 0. equal to sine 3 pi over sine 3 pi over 5 equal to 0 equal to 16 sine to the power of 4 3 pi over 5 minus 20 sine square 3 pi over 5 plus 5. Hence, theta equal to 3 pi over 5 is a solution. Okay. Okay, now the sapat II. Hence, show that sine pi over 5 times sine 3 over 5, 3 pi over 5 is equal to root 5 over 4. And the sapat C together, both the sapats together is getting you 7 marks if you can solve this completely. We have already solved the sapat I. Now we will be solving the II. Okay. And we are seeing sine pi over 5 and 3 pi over 5. We have already known that pi over 5 and 3 pi over 5, they are the solutions. They are the roots. So now we are having sine pi over 5 and sine 3 pi over 5. What is happening? How are we getting these signs in front? Okay. So let's see that. If we just consider this equation, because these two are the solutions of this equation. So let us take up this equation. So this can be taken as a sort of a, it is a trigonometric equation, but it can be taken as a polynomial equation as well. Suppose I write sine theta equal to a, then it becomes a polynomial equation. I'm writing 16a to the power of 4 minus 20a square plus 5 equal to 0. It is a polynomial equation of degree 4, but if I take degree 4, then I should be getting 4 roots. But over here, I know only the 2 roots. I do not know the other 2 roots. So I cannot take it as degree 4. I have to convert it to degree 2. So what do I do? So I can write this as, say, over here I am writing. I can write this as, let k is equal to a square. If k is equal to a square, then k will be equal to sine square theta, because a is equal to sine theta. So k is equal to sine square theta. You have to get the link between the relation between k and sine theta as well. Okay. I am taking this substitution. I am doing the substitution just to convert this degree 4 polynomial equation to degree 2 quadratic one. Okay. So what can I write? II 16 sine to the power of 4k, theta minus 20 sine square theta plus 5 equal to 0. Okay. And I'm directly taking k equal to sine square theta. I'm writing it in quadratic form. I have taken an intermediate variable just to show you, just to explain that I can make it appear to be a polynomial equation of degree 4, and then I can convert it to degree 2. Okay. So now that I know the whole thing, I'm just doing a single substitution. Let k equal to sine square theta. Okay. Therefore, 16 sine to the power of 4 theta will be k square minus 20 k plus 5 equal to 0. Okay. And now since it is a quadratic equation, it will be having 2 roots. And we know theta equal to pi over 5 and theta equal to 3 pi over 5 are the 2 roots. Also, sine square pi over 5 and sine square 3 pi over 5 will also be the roots, because k is sine square theta. If I take this one, like if I write this sine 16 sine square theta, in place of k I am writing sine square theta whole square minus 20 sine square theta. I am taking sine square theta as the variable. Then now it is a quadratic equation, therefore I'll be having 2 roots. And what will be the 2 roots of this quadratic equation? I know theta equal to pi over 5 and theta equal to 3 pi over 5 are the two solutions. Therefore, sine square pi over 5 and sine square 3 pi over 5 are the two solutions of this equation. You may introduce this variable k, or you can just write it in this format. Okay. And I have converted this polynomial equation of degree 4 to degree 2. So now it is a quadratic equation which is having only two roots. And these are the two roots, sine square pi over 5 and sine square 3 pi over 5. So therefore, product of the roots is equal to sine square pi over 5 times sine square 3 pi over 5 will be equal to c over a. This 16 is a, this minus 20 is b, and plus 5 is c. So this will be equal to c over a, therefore 5 over 16. Okay. Therefore, taking the square root of both the sides, sine pi over 5 times sine 3 pi over 5 will be equal to root 5, and over root 16 is 4. But you may say that why aren't we taking the minus sign? Valid question. Whenever we take the square root, we take both the signs, plus minus. But we reject one of them sometimes. Over here, we are rejecting the minus sign. Why? Because pi over 5, which angle is it? Pi is 180. 180 divided by 5, you can just do it over here. It is 5 times 3 is 15, and this is 30, so it is 36 degrees from the first quadrant. So sine pi over 5 will be a positive number. Sine 3 pi over 5. Pi over 5 is 36 degrees. So 3 pi over 5 will be what? This is equal to 108 degrees. 3 times 6 is 18. So carried 1, and 3 times 3 is 9 plus 108 degrees. In the second quadrant, sine is positive in the first and the second quadrant. So sine 3 pi by 5 will also be a positive number. If you multiply two positive numbers, obviously the product will be a positive number. So therefore, I am not taking the negative sign, I am taking the positive sign. Okay, I am writing that negative sign, a negative root is rejected because both sine pi over 5 and sine 3 pi over 5 are positive. Okay, so this is the value that we had to show, and we have shown this. So this completes our question number 12. It completes the solving of November 2023 paper 1. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please subscribe to my YouTube channel. It will be motivating me, and it will be telling the YouTube that my videos are worth watching. So the YouTube will be showing my videos to more numbers of students. So indirectly you will be helping me, that is direct, and you will be helping other students also. And we meet again very soon in our next session. We'll be starting to solve the November 2023 paper 2. So till then, bye.